Hey, my name is Taylor West, and this is my Immunology video 4. And today I'm going to be talking about monoclonal antibodies. So, in this video, I will be talking about what monoclonal antibodies are, how are they being used, and specific ways they can kill cancer. And I also will be ending the video on how they are made. So, to start off, we have what are monoclonal antibodies? These are laboratory-produced molecules that are to serve as substitute antibodies. These are made to bind to only one substance, so they are monovalent affinity. So monoclonal, mono stands for single, and then clonal. So this is produced by a single clone of B lineage cells. What are they being used for? So they're used to treat some kinds of cancers. They can be used alone, or they can carry drugs or toxins or radioactive substances directly to cancer cells. Monoclonal antibodies were seen as a potential opportunity to specifically target tumor cells while leaving neighboring healthy cells undamaged. So this is important because cancer cells look like self. So when you have an anti-cancer medication, it was hard because this medication and these treatments were targeting healthy cells as well because the cancer cells looked so much like self cells. So it was important because monoclonal antibodies targeted these specific tumor cells and left the healthy neighboring cells undamaged. Oh, skip some. Sorry. Um, they're being used for cancer. So the specific ways that they're being used, they can competitively bind to cell surface receptors and prevent their activation. They can interfere with generation of new blood vessels. They direct bind to receptors with induction of apoptosis. They can have induction of ADCC. They can have induction of the complement fixation, and they can deliver toxins. So these are some of the things, some of the ways they can specifically kill these cancer cells. So now we are going to talk about how they're made. So these specific monoclonal antibodies are made by taking a B lymphoma immunoglobulin and a human myeloma cell and fusing them together. So then you take this cell that you've infused and you inject a mouse with the antigen containing this specific epitope of interest. So first you take the B lymphoma immunoglobulin and the myeloma cell and fuse them together, and then you inject this into the mouse containing the specific epitope of interest. So then each B cell produces a single type of antibody. So these B cells are then isolated from the spleen of the mouse and then mixed with mouse myeloma cells. These two cells are then fused together to form cells that we call hybridoma cells. So you take the B cells out of the spleen of the mouse, fuse them with mouse myeloma cells, and this forms hybridoma cells. The B cells, myeloma cells, and hybridoma cells are cultured under conditions that will permit the growth of only the hybridoma cells. So all these cells are put into culture under conditions where only the hybridoma cells are growing, and that's what we need because each hybridoma cell will produce an antibody for a specific epitope. So then we look for the one that we need. And so the hybridoma cell that's producing the desired antibody, so what we need, are then taken out and cultured themselves. So we see what we need and we take it out and culture it alone. So then the monoclonal antibodies from these hybridoma cells are then isolated and purified. So there's a lot of steps to this, but it's important to make these steps. So just to repeat, we inject a mouse with antigens containing the specific epitope. We take the B cells from this mouse from the spleen and infuse them with myeloma cells. These myeloma cells and spleen cells fuse together to combine to make hybridoma cells. These hybridoma cells are then cultured to produce specific antibodies. So we look for the specific antibody being produced by this hybridoma cells that we want. So we want a specific antibody to attack this target cancer cell. So we look for that specific one. We take it out and then we culture it. Then we take the monoclonal antibodies from that hybridoma cell and we isolate them and purify them. So that's all I have today, and thank you for watching.